Hello and welcome to this very brief video on regions which finishes this chapter. So when we consider inequalities in x and y, our answers form a region rather than a set or sets of numbers on the one-dimensional number line. So we'll be looking at the x and y axes. So casting your minds back to GCSE, a typical question might look like this. Shade the region that satisfies these inequalities. And then here we've got 4 inequalities to satisfy. So looking at my bullet points, the first thing you'll do is to plot the lines as if the inequalities were equations. So for example, y equals -2, y equals 3x plus 2. Note, by the way, that if an inequality is a strict inequality, that means less than or greater than rather than less than or equal to or greater than or equal to, we would use a dashed line rather than a solid line. So as you can see on the diagram, y equals 3x plus 2 is represented by a solid line, and x equals 5 is represented by a dashed line because it was x is less than 5. Then we need to shade the region which satisfies all the inequalities, which may or may not be the region in the middle. An A-level question, on the other hand, is more likely to look like the example here and involve curve graphs such as quadratics, cubics, quartics, or reciprocals, which you learn how to sketch in the next chapter. So the question asks us to shade the region that satisfies the inequalities 2y plus x is less than 14, which is a strict inequality, and y is greater or equal to x squared minus 3x minus 4. So we have a linear and a quadratic. The linear is strict and the quadratic is not strict. So the region that we want that satisfies the two inequalities is the region below the straight line, because 2y plus x is less than 14, but above the quadratic curve because y is greater than or equal to x squared minus 3x minus 4, and you can see that region shaded in the diagram. Thank you for listening.